You know that feeling when you read a headline about some amazing scientific breakthrough, but then you just never hear about it again? Yeah, there's a reason for that. Today, we're diving headfirst into a huge challenge facing the world of research, the credibility crisis. But more importantly, we're not just going to talk about the problem, we're going to lay out a clear 7-step blueprint for how we can rebuild that trust. Okay, let's get into it.
So, here's our game plan. We'll start by unpacking this credibility crisis. Then we'll get into why research isn't always so transparent. After that, we'll shift to solutions, how to collect and prepare data the right way. And finally, we'll tie it all together to see how we can rebuild trust in science.
All right, Section 1, Science's Credibility Crisis. This really boils down to one critical question. What happens when a scientific finding just can't be repeated? It's a huge deal, because it really shakes the very foundation of how we think science works.
And that brings us to the heart of the matter. There's this growing feeling in the scientific community that something's off. A whole lot of published studies, when other top-notch researchers try to do them again, well, they don't get the same results. This is what everyone's been calling the reproducibility crisis. And what's really wild is just how widespread this is. We're not talking about one little niche field having a bad day. This is hitting economics, the natural sciences, you name it. If a result is just a one-off, a fluke, then other scientists can't verify it and they definitely can't build on it. Progress just stops.
So, how did we get here? Well, the answer really comes down to one word: transparency. Or, a lack of it. The problem is often buried in all these hidden steps. The little decisions a researcher makes along the way that aren't written down, but can totally change the final outcome.
I love this quote. It just nails the issue. Think of a scientific paper like a dish from a world-class chef. The final result might look and taste amazing, right? But if the chef won't share the recipe, you have no way of making it yourself. You can't trust it. In science, the methods section is the recipe. And if that recipe is sloppy or has missing steps, the whole dish is suspect. The source material actually breaks this down into two different but related problems. First, you've got results reproducibility. This is the basic stuff. If I give you my exact data and my code, can you punch the numbers and get the same answer I did? But then there's a deeper level, inferential reproducibility. This is about the conclusion. Even if you get the same numbers, is it reasonable to draw the same big conclusion from them? You absolutely need both.
So why aren't people sharing the full recipe? It pretty much boils down to two things. First, a simple lack of knowledge. Some researchers just were never taught how to do this properly. And second, a lack of motivation. Let's be real, if the top journals don't make you share all the details, there's not much of an incentive to do all that extra work.
Okay, so that's the problem. Now let's get into the good stuff, the solution. We're going to start at the very beginning of any study, collecting the data. If you get this part right, you're building a solid foundation. This is where transparency has to kick in.
The source gives us a fantastic 4-step blueprint for this stage. It covers how the study was designed, what variables were controlled for, how people were sampled, and, really importantly, how any missing data was handled.
First up, research design. This is so fundamental. If you want to claim that X causes Y, your design has to be rock solid. Researchers have to be crystal clear about the details, like when the data was collected and whether they used a control group. These are the details that let us even begin to talk about cause and effect. And the consequence for messing this up? It's simple, but it's a big one. Without a clear and proper design, we're just left guessing. Sure, you might see a connection between two things, but you have no idea if one actually caused the other. The whole point of the study just evaporates.
Number 2 is all about control variables. These are the other factors you measure to rule out alternative explanations. But we need to know why specific ones were chosen. And more importantly, were there any that were measured and then just quietly dropped from the paper because they made the results look less exciting?
And here's what it looks like when it's done right. This one study didn't just list their controls, they explained the why for every single one. For example, they controlled for the sex of participants because other studies showed it can impact how we perceive leaders. That's what real transparency looks like.
So let's just boil this down to 3 simple rules. 1, every control variable needs a clear reason for being there. 2, no hiding things. If you measured it, you report it. And 3, put all your controls in the main data table so everyone can see how they relate to everything else. Simple as that.
Practice number 3 is sampling. We've got to know exactly who was in the study. Who are these results actually about? How are they recruited? If you used a big database, which one was it? Without this info, we have no clue if the findings apply to, well, anyone else.
And the fourth practice for data collection is about missing data. Look, real-world data is messy. There are always going to be gaps. Researchers have to be totally upfront about how they dealt with them. Did they just drop those cases, or did they try to fill in the blanks? That one choice can massively swing the results.
Okay, so you've collected all your data following these best practices. You're not done yet. The next stage is preparing that data for analysis, and this involves another set of huge judgment calls that absolutely demand transparency.
For this data prep phase, the source points to 3 more key practices: how researchers deal with extreme data points, called outliers, what kinds of statistical corrections they might apply, and whether they transform the data in any way before analyzing it.
So, first off, what even is an outlier? Well, it's basically a data point that's just way out there compared to everything else. It's the oddball. And because it's so different, it can have this huge, outsized pull on the final results, potentially dragging the entire conclusion of a study in one direction.
And this is where it gets really tricky. When you see an outlier, what is it? Is it just a typo, a simple data entry mistake? Or is it a real, super influential case, like the one Michael Jordan in a study of basketball players? Or maybe, just maybe, it's a fascinating discovery all on its own. Deciding what to do is a major judgment call.
This brings us to our 5th best practice. Be transparent about managing those outliers. Researchers need to spell out their rules for dealing with them before they even start. And ideally, they should show us the results both with and without the outliers, so we can see for ourselves what kind of difference they made.
Now get this. In many of the social sciences, if a measurement tool is 80% reliable, people say, hey, that's pretty good. But that means 20% of what you're measuring is just random noise. Can you imagine trying to land a rover on Mars with a 20% error margin? No way. It would be a total disaster.
So to deal with this, we have our 6th practice, artifact corrections. These are clever statistical techniques that try to estimate what the results would look like if our measurements were perfect. It's a totally valid thing to do, but only if you are completely transparent about the methods and assumptions you used.
And our 7th and final practice is about data transformations. Sometimes researchers need to tweak their data to make it work with certain statistical models. But way too often, they don't explain why they did it or what effect that tweak had on the final results.
So let's bring this all home in our final section. We've just walked through 7 very specific practices, but they all point to one single powerful idea: rebuilding trust through transparency. It's about realizing that sharing how you got an answer is every bit as important as sharing what the answer was. And this right here is the main takeaway. These 7 things aren't just, boring technical details for statisticians to argue about. They are the absolute foundation of scientific credibility. Without them, the entire house of cards gets pretty shaky.
At the end of the day, if the methods aren't trustworthy, we just can't make progress. The key to making science reproducible is transparency. It's that simple. When researchers share their full recipe, the whole scientific community can check it, they can repeat it, and they can build on it with confidence. It lifts up all of science. And that leaves us with one last, pretty mind-bending thought. If we all agree that the recipe, the method, is the most important part of the whole meal, maybe we've been looking at science all wrong. What if we started judging research on the quality and transparency of its methods before we even get a peek at the results? It's a radical idea for sure, but it's one that could truly change science for the better.